So, good evening to everyone. Today we are discussing about science and logic STLD topic. This is a seminar for the STLD, uh, exploring the fundamental circuits and memory and store information. Science to logic circuits. Hatch hatch versus flip flop, the key differences. What is today we discuss now discussing about what is hatch and what is flip flop, what are the difference. A latch is a circuit that latches onto the value. Its output can be changed as long enable signal active. This makes the transparent and the output directly follows the input. Well, even enable this can be sometimes can be unpredictable. Flip flop. A flip flop is a smart. Its output only changes. Precise says smarter only changes at the precise moment. Lock signal and transist and edge. The edge. The top, this is the typically the rising edge of 0 to 1 and falling edge of 1 to 0. Now typically in the flip flop there is a rising limit of 0 to 1 and a falling limit of 1 and 2, providing the stable synchronous data storage. Here the latch is targeted in level targeted. Latch is level targeted and flip flop is edge targeted. Here we clearly see this make the transparent and output directly follows into input and enable this sometimes unpredictable. Latches are sometimes unpredictable. So we can say the different type of latches. We can see SR latch. SR full form is set rest. SR latch is the most basic synchronous circuit built from two crosses completed to the gates like NOR gates and showing here. And S when S1 and R equal to 0, the output Q is set to 1 and R is set when R is 1 and S is set to 0. It is Q, then Q reset to 0. Invalid state. If the S and R are both 1, the circuit enters invalid and unpredictable state. This is its main drawback. Now we can clearly see that S and R are both 1. When S and R are both 1, circuit enters to invalid state and unpredictable state. Here we can see we said that latches are unpredictable in this last point. In this SR latch also, it is when the S and R are both are kept to 1, then the output is kept to unpredictable and we can't even predict what will be the output. And we can say after SR flip flop, this is D flip flop. D flip flop is the most common type of solves the SR latch invalid. Here D flip flop solves the SR flip flop's disadvantage. Here both S and R are when comes to 1, it output will be unpredictable. Here that will give here solution. In this the D flip flop solves that problem. It simplifies the clock edge and output Q becomes whatever the input D. Q equal to next equal to D. This makes it fundamental building block of for memory registers and where it holds a bit of data. Here in this D flip flops, it replaces SR flip flop because it holds some data and it solves the problem of SR is 1, it is unpredictable. It solves that drawback here. JK flip flop, it is also called as a universal Universal flip flop. The JK flip flop is an enhancement of the SR flip flop, and it also often called as universal flip flop. J acts as S. Here the JK flip flop acts as J acts as S, and R is reset, and K is reset. K acts like R when J and K are 1. Here in the SR flip flop, in the SR flip flop, SR and S and S equal to R and R equal to 1. Here that will give unpredictable value. Here J equal to 1, K equal to 1. Here automatically Q reset to 0, and in J Q reset to 1. Key feature: J when J equal to 1 and K equal to 1, invalid state replaced by toggle state. Here the SR flip flop drawback can be reduced by JK flip flop by simply in invalid state it immediately immediately jumps to toggle state, and output flips to Q becomes Q naught. The T flip flop with the toggle flip flop. Here we discuss the toggle state in JK flip flop. A T flip flop is simplified version of JK flip flop where JK is tied together to form T flip flop. Here JK flip flop both are merged together to form T flip flop. T equal to 0 and T equal to 1. The output Q toggle will flip on the clock edge, and Q holds to previous state. This simple toggle or hold behavior makes it perfect for building frequencies and individual and binary counters. Sorry for the T flip flop is simplified version of Q. In J flip flop where J and toggle. Okay. Here T equal to 0, the output Q holds the previous state. Then if T equal to 1, the output Q toggles flips the clock edge. Okay. Comparing the truth tables. A side-by-side state can be here to each flip-flop type. Flip-flop truth table S and R and T flip-flop. Here we can compare the both. SR flip-flop when S is 0 and R is 0, Q holds. When S is 0 and R is 1, its states to reset state. When S is 1 and R is 0, Q will be 1 and it will get to set, means it will goes to internal or it will get to set. When SR flip flop S equal to 1 and R equal to 1, we are previously we discussed that S equal to 1 R equal to 1, it will jumps to invalid state and it will be not give any value, and it will give any its own value, it will be wrong anyway. D flip flop D equal to, here D equal to 0 and Q equal to 0 is state to reset to data, and D equal to 1 and Q equal to 1 state to reset. Here only two possible ways is there here. Here comparing the JK and T flip flop. Here when J becomes 0 and K becomes 0, Q state will give Q statement holding, it holds the value. When J equal to 0 and K equal to 1, when Q turns to 0, reset 0 means it will reset the value. When J equal to 1 and K equal to 0, Q will give 1 means set the data. When J equal to 1 and K equal to 1, it will Q naught means it is the main difference for JK flip flop and SR flip flop. Here the 1-1 state will in the SR flip flop, in the 1-1 state will be invalid. Here the JK flip flop 1-1 will transfer to Q naught and it will give to toggle state. T flip flop means toggle flip flop. Here T equal to 0 and Q equal to Q, it will hold the value, and T equal to 1 and Q equal to Q naught, it gives the toggle state. It will easily give toggle state than JK flip flop. Real world applications of these flip flops are memory registration and counters and timers and state mechanism. Here we can see the groups of D flip flop are used to create register and store the data. Flip flops and D flip flops are used to storing the data, and D flip flops are used to store the data, and T flip flops are perfectly building the binary and frequency dividers are essential so digital clocks and timers. Here we commonly see the T flip flops in the digital watches and clocks, and wherever we can want. And the state mechanism, if any system want to do some mechanism work, it can be used. JK and D flip flop both are used it in the current state. It is finite state mechanism which control the complex logics also. We can control with this. Okay, thank you.